Hello, good morning students. Today in electrochemistry we discuss about electrolytic cell and electrolysis. Cell, there are two types of cell, primary cell and secondary cell. Depending upon the reaction, it is classified into again two types. Previously we have studied about electrochemical cell. Electrochemical cell means chemical energy is converted to electric energy. This electrolytic cell is electric energy. Electric energy is converted to chemical energy. Okay? Electric current is passed to the cell and it is converted into chemical energy. Means what? Redox reaction takes place. This reaction is known as electrolysis. So if you take particular cell, in that you fill up solution CuSO4 suppose, and you give current, positive and negative current, then electrolysis will take place. This electrolysis is nothing but it is electrolytic cell. At cathode, reduction will take place, and at anode, oxidation reaction will take place. Okay, this oxidation and reduction is depending upon standard reduction potential. Standard reduction potential of particular ion, if it is more as compared to that of hydrogen standard reduction potential is 0. If the standard reduction potential of particular ion or particular cell is higher, then its reduction is take place. But if its reduction potential is small, then instead of our cation which is reduced, the hydrogen gas will bubble from the water solution. So you kept in the mind, the reduction potential, if it is less, then its oxidation take place, and reduction potential, if it is high, then reduction will take place. Electrolysis, this electrolysis principle is depending upon the Faraday law. The Faraday law of electricity, first and second law. First law says that amount obtained at the electrode is directly proportional to the current passed. Current is equal to Q is equal to I into T. So first law of Faraday states that amount obtained during this redox reaction at the electrode means what? Cathode and anode, is directly proportional to current. Current, that is I, we measure in ampere, and time we measure in second. Okay, so Q is equal to I, and this is what? Coulomb. Second law, if same current is or fixed current is passed in an electrolytic cell which is joined in series, different cell is joined in series, then product obtained at the electrode is directly proportional to its chemical equivalent. Chemical equivalent means the valence. The product is directly proportional to chemical equivalence, or is directly proportional to the valence. When you balance the reaction, then you have to balance the electron depending upon the valence. Then product obtained at the cathode and electrode, if electrolytic cell is joined in series, then in different cell, different product is obtained, and that product is directly proportional to chemical equivalence or chemical stoichiometry, in other words. Okay, so remember this, Q is equal to I, that is the mean. Chemical equivalence means, suppose if it is copper, then Cu plus 2 ion takes 2 electron to reduce. So that is known as chemical valence is 2. Similarly, aluminum Al plus 3, then it takes 3 ion to convert into Al solid. So that is known as chemical. Suppose it is lithium Li plus 1 plus 1 electron is converted to Li solid. That is known as chemical equivalence. Okay, number of electron transfer also you can see. Now we take the example related with this electrolysis. We take the example related with this electrolysis. Before going to example, remember that the positive electrode, if it is positive electrode in the electrolytic cell, suppose this CuSO4 solution, suppose this is joined to positive current and this is joined to negative current. Then here positive current joined to the battery, then negative ion will rush over. If negative ion is there, then positive ion will goes over here and it will reduce. So negative terminal is the cathode and positive terminal is the anode. On cathode, reduction will take place. On an anode, oxidation. We come to the sum, that is a solution of CuSO4 is electrolyzed for 10 minutes. The solution is CuSO4. In that Cu plus 2 ion, by taking 2 electrons, it is converted to Cu solid. Okay, so its chemical equivalence is 2. 2 electron is required. So here, if you supply these 2 electron, then copper plus 2 ion will reduce to copper solid. Now Q is equal to IT. I, that is the current ampere, it is given, it is 1.5 ampere current is passed. So here it is 1.5 ampere. Time T is given for 10 minutes. We have to convert this minute into second. So it is 10 into 60. So it is 600 seconds. Okay, here Q is equal to 1.5 into 600. So it is coming 900. Okay, it is equal to coming 900. 900 coulomb. See. Now we compare how many grams of copper deposit at the electrode, means cathode. We want to find how many grams of this. So you see the stoichiometry first. Here it is 2 electron. 2 electron means what? 2 Faraday. 2 Faraday if current is passed, then 1 mole of copper is equal. Cu. And 1 mole of copper is equal to its atomic weight, 63.5 gram. 2 Faraday. Okay, 2 Faraday, if you want to convert into coulombs, then it is 2 multiplied by 96500. Whatever answer comes, that answer is in coulomb. So we put another statement that if 2 multiplied by 96500 coulomb, then it will give 63 gram, 63.5 gram copper. Then this much, 900 coulombs. If you current pass, then how much gram of copper will be deposited? So if you multiply 900 into 63.5 divided by 2 into 96500, then answer will equal to 0.2938, 0.2938 grams. Okay, 2938 grams. So in this way, you can find how many grams of product obtained at a particular thing. Okay, but practically, this is theoretical. Practically, if you find it, then value is not coming this. For that, we have to find the efficiency of the cell. Okay, no cell is 100% efficiency. So product octane, practically product divided by product octane theoretically multiply by 100. That will give the value of efficiency of the cell, and it is always less than that of 100. Okay. So try to solve exercise question related with this electrolysis and complete this in your notebook. Electrolysis, and remember the formula Q is equal to IT, this Coulomb, and from this equation Farad is there, Farad you convert into Coulomb, and you compare the cell with given cell and what is given in your sum, and from that we can find the grams of product obtained at the electrode. Okay, thank you.